Hi, everyone. Thanks for tuning in to the Printed Circuit podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez. This is officially the first episode of season 3 of the Printed Circuit podcast. Last year, we discussed PCB design best practices based on 5 pillars of digital transformation. For this season, we've selected topics based on listeners' and followers' interest, requests, and feedback. So in this episode, we'll focus on design automation. And here to join me in this discussion is John Medina, owner of High Speed Design Services. Thanks for being here.
Thanks, Steph.
John, can you give the audience a brief introduction of yourself?
So my name's John Medina. I own High Speed Design Services. We focus on PCB design and package design. I have 30 years experience with both PCB and package design and some signal integrity. So I often say I can do the low-hanging fruit signal integrity automation stuff and signal integrity analysis. So I've been using pretty much all the tools out there: Siemens, Hyperlinks, Cadence, Altium, PADS Professional. And I've been doing co-design and SIPI services for high-end commercial companies and many defense contractors. So my background is completing PCB and high-density advanced package designs and also delivering PCB training. I've worked at many places, including Apple, Northrop Grumman, Agilent, and Cisco, and other places. And Intel has been the latest company I came from doing package flip chip design. I also worked for Mentor Graphics, supporting the packaging group as field application engineer. And I have a patent on bump compensation methodology, which ties directly into automation. That's my brief background.
I got to tell you, it's extensive background, and you definitely have covered the gauntlet, so you bring a lot to the table, and I'm very excited to engage this conversation with you. My first question to you is, though it might seem obvious, do you use automation in your PCB design process? And then if so, why?
There's 2 key words there. I definitely use automation, and I really believe that my process has to include automation. So it's like one can't be without the other. So I use both in my process, as much automation as I can. My rule of thumb is if I have to do something more than 3 times manually over and over, I try to create a script or try to create hotkeys or try to create something to save time, because I know that I'll be doing the same routine over and over. So instead of using 15 keystrokes or many types, I try to do a hotkey or something that will just automate that process. And it saves a lot of time and increases productivity in all cases.
I am the same way. I embrace the automation, and I use it with control, and I use it when the opportunity presents itself. And when I attended industry conferences like the one I just came from earlier in the week, which was PCB Carolina, it's amazing when I asked, in my technical session that I presented, of how many of you in the audience utilize automation, like auto router, for example, or auto placement within your tools. And nobody, I'm not lying, and I had like maybe 50, 60 people in the audience, and like nobody raised their hand. And it's surprising to me because they have the tool and the capabilities that the tools they use today, but yet they're not embracing that automation. At what point in your career did you make the decision to implement automation in your design process, and why?
I think it was very early on, and I'll get to this point too, but I think a lot of the CAD tools have evolved and include automation now. So it's out of the box automation that's included. But when I first started using automation, it was back when I was outputting Gerber files and assembly drawings and drill files, and it was really before ODB. So inside of the tool itself, I was using FabLink at the time. You had to go through 16 different steps to do all the outputs. And right there and then I said, there's got to be a better way. Once we've done all our design rule checks and everything's clean, it should just be a button push that dumps out all the Gerber files and the drill files. And actually, I've already created the fab assembly drawing, so just dump out the PDF files. So I created a script that would do the whole post-processing process.
For me, in my career, it was probably about 15, 20 years ago when I was actually consulting. I worked for a small engineering firm, and we were under a tight deadline. And in order for me or for us to hit that, I had to give it a shot and give it a try, because there was no way I was manually going to do it. I utilized the auto router, and at the time, I was so dead set against automation or utilizing auto router because I felt like I needed to control that bounce. Like all the other designers today, I got to feel like I'm in control and be in control. And I felt using the auto router, I wasn't. But it turns out it was successful. I was able to use it effectively and efficiently. And I was shocked on how much time it saved. And allowing the ability to do what if scenarios and come with some different versions of a board. That was huge. And it was really eye opening for me. And from that moment on, I embraced it and I ran with it. And like you said, early in our career, both of us, it was the next evolution. And, now you and I are industry veterans and I can't see not doing automation. So, yeah. So give me your opinion on designing PCBs without automation, especially when it comes to today's challenges and complex designs. So think about today's complex designs. What is your opinion? Do you think, can it be done or can we continue to do these designs as the industry evolves without automation?
The short answer is you could, but it's going to take you a lot longer. So let's take an example, a real life example. Let's say you have a very high pin count BGA. Now, you could break that out one pin at a time. Let's look ahead. And that's why I'm thinking about our process here. It's like, okay, what am I going to do once I break this out? I'm going to route it. And how am I going to route it? So initially, I want that breakout to happen very quickly. Now, I may have a pattern of a breakout that I'm thinking in mind, or I may want the tool just to do the PCB fan out for me that I'm thinking about from our auto routing. Well, we'll get back to the auto routing point in a minute, but let's talk about the BGA breakout. So let's say you do it manually, you have 1,500 pins. So how are you going to do that? One pin at a time? That's 1,500 keystrokes at least, if not more. So if you can automate that and do it in a matter of seconds and get the pattern you want based on your knowledge you've done before, that saves a lot of time.
I couldn't agree with you more, especially when you talk about high pin count BGAs. Just fanning out in quadrants sometimes isn't good enough. You need to be able to fan out with effective strategic planning and utilizing this automated fan out. You can strategically fan out in different dog bone sections, or maybe you don't fan out. In that case, a fan out maybe is via and pad because the pin pitch is so tight. And that's your best alternative of how you're going to attack the design. And
you think about that, like you're saying, the breakouts, and you think about HDI taking over from through-hole vias, there's a whole gamut of different stack-ups that you need to think about it, the different methodologies, how you break it out, what's better for power delivery, what's better for signal integrity, what kind of high-speed SerDes do you have on that BGA? So there's a lot of thought that goes into that. So it's not just a dog bone anymore, or not just quadrants. And then if you think about package designs where there's 50,000 pins, you're not going to break that ASIC out in one by one. You want something that is V and pad. You select the whole ASIC and it just dumps it out. Now, the HDI, you're thinking again, power delivery and signal integrity. Are my high-speed nets, are my SerDes at the edge of that BGA? And I don't even want to break out. Maybe I want to route on a top layer and go directly to the connection without a via there, because that via may cause other problems down the road, like reflections. And when you think about just a simple example of a BGA, there's so much thought process that has to go along with that. So again, just the planning is a lot of time. So you need the automation once you made a decision. How do I get there quickly?
You're absolutely correct. And when I think about early in my career, back in the day, when the efficiencies and tools just weren't there. And I remember doing via fan outs or doing BGA fan outs. I'd use a graph paper and colored pins, and then I'd draw the matrix of the BGAs. And then with colored pins, I'd say, okay, this is how I'm going to get out of here. And I'd draw it manually first, whether I was doing it on a pad and pen or I was using Visio, okay, this is what I'm going to do. And then I would go implement it. We've come a long way when you think about it with the automation of today's tools. You talked about some scenarios. Can you highlight some examples of design automation functions that you use in your projects, such as the tools we have today, like auto routing or sketch routing or interactive routing, plow routing, and placement? Can you give me some examples that you've utilized?
I have 3 good examples I can talk about. The word auto routing sometimes is considered a bad word. So I really call it the automation of hand routing. I use that term especially when I'm talking to engineers and managers, is because if I say auto routing, they're like, oh, you're just going to hit a button. No, I'm planning what I'm going to do. So the sketch planner is a great example. So in that example, I can plan out what I'm going to route. I can show the transition vias where they're going to be, and I can easily move those sketch plans around before I drop one trace in place. So I can show that at a design review meeting. Say, early on, we have breakouts are in. Now here's my sketch plan cartoon. Basically, it's like, this is what I'm thinking. This is what we can use. And also that helps me determine the layer count. So at that point, if I say, okay, this looks good, then I'll use what we call the trunk router, which will just route from one end to the other end. And in package land, if I do packaging, I may have the option to pin out my BGA any way I want. So by using the sketch planner and the trunk router, I can go from the die to the package and then unravel at the ends. So that's for package. But even in PCB land, I may be able to swap byte lanes around once I get to the memory. So even using the trunk router allows me to do some planning and then swap pins once I get there. Instead of routing all those traces one by one, I'm using the sketch router and the trunk router to accommodate fast routing, good planning, and visualization of that routing. So I'm not in a vacuum. I'm sharing those ideas with the engineers before I even plan one route. And they can say yay, nay, or whatever. And yes, you have a good return path or you don't. So I think the sketch router, sketch planner, trunk routing, and trunk routing is a very good option to use. The other example is plow routing, where I can do multi-plow routing. So now I say, okay, I have a whole bus here of, let's say it's some kind of interface where I can just route the whole bus together. I can select all the routing and basically do plow routing and route the whole bus in one single keystroke. There's also an option for multi-hug routing for flex designs. That's very powerful. So you can say, let's follow the contour of this flex route. Start here and stop here and route these 16 lines all together at once. And if you ever done flex designs or curved routing, one by one is not fun. So if all those together, that's a huge time saver. And the last one is the component placement. So I use physical reuse to no end today. Like if I have repeatable circuits, I'll create a physical reuse sub-circuit and maybe also combine that with complex via patterns, and I do BGA breakouts. So let's think about those three things. Those are all big things. So I have a physical reuse block that I use to break out the BGA, for instance, and I route to, let's say, my termination resistors, or I route to my capacitors that are in line, and then I use complex vias to make those transitions. And then I have a BGA breakout, we're talking sometimes in package land, and then I use the sketch router between all those three things. So now I've combined physical reuse, complex vias, and sketch routing to do exactly what I need to do very quickly. And if ECOs happen, I have a quick way to recover and use those three things all over again.
The way I say it is you're definitely preaching the gospel here from the way I think of attacking efficiency, utilizing the automation. And I think the biggest thing with automation is to be able to do like what if scenarios, as well as to be able to handle changes. Because let's be real and let's be honest, changes happen continuously throughout the design cycle. And the manual approach is that when there's a change, it's okay, 2 steps backwards and then a step forward, or in some case, 10 steps backwards. But I think when you utilize automation, it's not a step, it's just a pause. It's a pause, and then you re-engage, because the automation allows you to be able to make the change and then re-engage and go forward without too much of a negative impact, or not at all, to the process of you're during your design cycle to handle changes. And I think that's the biggest thing. And I love what you said, the phrase about, what did you say? Something like manually controlling.
Yeah, it's the automation of hand routing. That's what I call it.
Yeah, the automation of hand routing. I love that. And it's true. When I talk about automation and I get in debates, whether it's in conferences or on LinkedIn, discussions, and the majority of people are, I will never auto routes, no, the tools aren't good enough today. I just don't push the button. I don't create a plate of spaghetti. I control that power, the horsepower of the tool, to allow me to get where I need to be successful with the design outcome. So when I do the analysis, it's in the target parameters of where I need to be. And I think I know what you described. That's it. That's in the pocket of success. And that's why I think you've been successful for so long in your career, because of that, because of your approach. And I love that. Can you share with me any other real project or examples in which automation improved the design cycle time? And then maybe share like, hey, this is what happened when I didn't use automation and it took me this much longer, whatever the case. Do you have anything like that?
I do want to talk about the automation hand routing again real quickly. So let's say you use a sketch planner and then it doesn't really work like you really want to. At least you've done, I'll call it a dipstick route, meaning that you've proven it can route it. Now, if you want to route manually one by one or a multi-plow, you can, but at least you've got a plan. You see what you can do. And let's say you don't use the sketch router. Well, that's okay. At least you understand that plan going forward. So I guess that kind of ties into your last question here. If you don't use that automation, don't do a dipstick route, and you do everything by hand, you might find out you got a roadblock and you've already routed a whole bunch of stuff and you don't have enough layers. And why don't you have enough layers? Because you didn't plan it out. And so using automation, the sketch planner and things like that, and even the Unravel capabilities that are out there today, these things can all help you. But if you don't use planning, again, if you don't have a solid process, you can get way down 6 months into a project, 3 months into a project, and say, I don't have enough layers, or we're not meeting our signal integrity requirements because we have a through-hole via and it's not passing our eye diagram simulations and we have reflection. So we have a problem. So one example I can give you is I'll do DDR planning using Expedition Substrate Integrator. That's the package, and a PCB co-design floor plans together. And I can see both the ball out and I can see the from the die to the package and the package to the memory on PCB. And so using all those things together and unraveling allows me to plan in detail from the die to the package to the PC board. And I can use things like Unravel, and I can use things like the Sketch Planner, even if I manually route later to save time. And again, if I don't have those tools, I don't have that, imagine how long that would take using Excel and Visio and a whiteboard.
Most service bureaus, at least the high-end ones or the upper level ones, are speed and quality. How fast can you get it done and the quality you're bringing to the table? Speed is the key, is how fast can you do it? So when you're bidding a job, hey, I could do it in 10 weeks. Well, why are you 10 weeks when everyone else is like 6 weeks? There's a chance you may be losing bids because you're being outdone by your competitor. We think of the world and how competitive it is. It's faster, better, and what kind of quality you bring to the table. And to think about utilizing automation, the designs are just getting too complicated and smaller and faster. And our tools have the ability to make us better. But we are the ones as humans have to engage that and use it to our advantage. And the way I would say is try to get the 18 hours of effort in an 8-hour day rather than to work the 18 hours. You've just described it, but with all the automation that you said you've done. John, a few weeks ago, you and I had a great conversation, at PCB West. We talked about how do you address topics about automation in PCB design when you're in conversation with other designers who really don't buy into it. For example, like routing signal traces and stuff, because I had came out of one of my sessions and I had told you that we got into some good discussions regarding the lack of people in the audience who do not embrace automation or who don't embrace auto routing. So how do you have those discussions when you talk to other people? I know it's not just me. So
one trick I learned when I was an application engineer for Mentor Siemens was to listen. Instead of preach, I would listen. So I would ask them the question, okay, show me how you route this DDR, for instance, and then show me how you tune it, and let me see that process. So I would let them show me that. And let's say they weren't using automation. I know it's going to take time. So let's just do one byte lane. So they route it by hand, of course, and then they tune by hand, of course. And so, that's all fine and good. And so I want to be careful here because there is good quality work that is done manually. It just takes time. So I'm not saying don't do manual good quality work, but use the tools to do both. Do good quality work, but do automation. So then I would ask them to show me their example. And then I would take the same example and do the same thing that they did, but I would use automation. I would use the techniques of the tool to allow me to route quickly and use the tuner. And then I may come back and interactively tune one by one and look at the constraint rule system and make sure that I'm meeting those rules. But I would compare times and say, look, is this better? Is this faster? And still get the same results. And then take it a step further, take that byte lane that I routed and tuned, and then do simulation on both and see if they're comparable. If they are, and I saved X amount of hours, then that should be the convincer.
You nailed it. That is key. It is in the discussions that I have, I do what you say. I listen, I hear their point of view. And in the end, I just say, the fact is that money talks, time talks. In the end, it's about money and time. Can you save money, and how much time can you save? When you're delivering, your product, especially your design cycle, you're always looking to see how you can reduce the design cycle and still bring to the table the highest quality with the least cost and with the highest yields possible. Automation today allows us to do that, but you have to embrace it. You got to embrace it and use it to your advantage. When we think about the role of the designer and the designers in general in today, what are your thoughts on the evolution of the PCB designer's role in the industry as our industry unfolds or continues to move forward? That's the first question. The second question is, do you think the designer's role will ever fade away, especially with the evolution of AI?
So I'll take some words out of your question, but it is really the evolution. And so I don't think PCB design will fade away. It's impossible. And I think package design won't fade away either. It's necessary. And AI will not take over the job. It may help, but it's not going to take over the person's experience and knowledge of PCB design. So what I see, it won't go away, but it is evolving. Designers will need to stay aware and embrace change with new techniques and best practices in order to adapt to technology, especially considering AI type designs, meaning there's a lot of high speed SerDes, there's PCIe Gen 5, there's DDR, there's a lot of stuff that has to be in AI designs. I'm not talking about AI taking over, I'm talking about doing AI designs and the constraints that need to be met for these high speed requirements. So in other words, the PCB designer is going to have to keep up, with the demands. And the way to keep up is through automation and experience and seeing examples and being part of the evolution, not fighting the evolution.
When I have these discussions and I'm asked that question, hey, Steph, do you think AI is going to take our jobs? My response is no. You know who's going to take your job is the other human who is utilizing AI to his advantage. That person is going to take your job, or you will not be able to compete with that person or that company that is utilizing that. And I think that's key when we think about AI in general and the evolution of our thing. I think our field is set for designers. We will just evolve. I mean, all of us will as technology evolves and as our industry evolves.
And the other thing to think about too is, like, I've been doing this a long time and I see a lot of PCB designers retiring, right? And so, back in the day, we had schools that taught PCB design. So that's kind of my thing too, is like when I do get ready to do more of a retirement role, I would like to do training and education. And I think that's important that we keep that alive, especially for a lot of companies here that can't send PCB design offshore. They have to do it here. So I do think there's a little bit of a vacuum there that we need to keep our next generation of PCB designers informed and educated and trained. It's not just electrical, right? It's manufacturing, it's everything that goes into it. So I know a lot of old PCB designers, or I'll say experienced PCB designers, that know a lot about fabrication. And that's such an important thing that maybe some of the newer PCB designers do not know, and they need to know.
I agree with you. I think calling yourself a PCB designer or having the title is more than just being a draftsman from back in the day, what they would refer to as a draftman or e-draftsman. Today, a PCB designer, you've got to understand design, you got to understand manufacturing, you got to understand producibility. There's so much you need to cover. And this is why I love and I'm very passionate about printed circuit board designer or printed circuit engineering. There's so much more to it than just routing a trace and connecting a dot or drawing a schematic. There's so much more to it. And the devil's in the details. The devil's in the details. But this is a good prelude or a good segue into my next question is, how do you recommend to continue to evolve or develop your PCB design skill set when it comes to continuing education or when it comes to honing our craft and mastering our craft as printed circuit designers?
Yeah, that's a good question. One thing I do is I'll go beyond PCB land. So I'll name drop here like Howard Johnson or Eric Bogaton. I'll look at those guys for direction. And I'll look at the industry leaders on signal and power integrity. Why? It's not PCB design, but why? Because it's going to help my PCB design. So I always try to challenge myself by working on leading technology. Now, that's not something I can just ask for. So I have to stay involved with companies that are doing leading technologies. And that's what inspires me. That's what stimulates me, is to do the leading edge kind of PCB designs out there. So the thing I follow is SIPI developments, like who's doing what, how are they simulating, how are they extracting, how are they doing PCI Gen 5? What do they do for inductance and capacitance and cutouts? And look at that and adapt that into my best practices when I'm doing high-speed designs. But I also like attending shows like DesignCon, PC Design West, User to User, and see what the industry trends are and the new developments. And this helps me keep informed. And I also look at the PCB and the package technologies out there. Like, what's TSMC doing? What's Amkor doing? What are these guys doing? And I'm telling you, the packaging world is, I call it the wild, wild west, because it's constantly changing. How does that affect PCB design? Well, that chip is going on your board. So understanding from the chip level to the board level helps you stay involved and helps your skill set increase.
Yeah, you have to understand the fabrics, the different fabrics and how they interact, and how do you maintain that signal quality from the chip to the board to the outside world. When you think about the connectors, or you think about an electronic system where you've got multiple boards in a box, and you think of the signal quality. If you got multiple boards, you got a motherboard, you got a backplane, how's that quality of the signal going as it traverses through that entire length to get out to the real world?
Even the materials and fabrication, it keeps evolving. There's Nalco, there's polyimide, there's all kinds of stuff. And for a lot of space applications, it's constantly changing. And so being aware of just the materials and how you get better DK or lower DF, those things are important for high-speed designs. Now, when we talk about PCB design, you can talk anything from analog to power to high speed. So my whole conversation we're having today is basically focused on high-speed designs. That's kind of where I hone in at. So I think even understanding the materials and doing some research and seeing what's out there, FR4 has changed a lot in the last 20 years, right? So again, back to the fabrication, I think that's what makes a well-rounded PCB designer, is knowing from the fabrication to the signal integrity, power integrity, delivery, all those things, and know how to do PCB design makes a very well-rounded PCB designer.
I agree. And I think, one of the statements I always say is, as a PCB designer and just in general for engineering, is you have to understand the decision you make at that moment and what is the effect or the impact downstream. What is the impact downstream, whether it's fabrication or whether it's assembly? You have to know what you're doing at the moment, the time you're doing it. And what is the impact going to be? And I think as a designer, you need to know that. You need to be educated. And I think that you're right, spot on with about the industry conferences like PCB West, PCB East, PCB Carolina, DesignCon, even SMTA. That's a great one. They got great things going on there. IPC Apex is another great one for assembly and manufacturing. There's so much good content out there, and there's a lot to be taken advantage of, where you're going to get education to a certain point in college, but you're not going to learn how to design a board correctly in college. I'll tell you that. Very few, if any, major college or universities teach printed circuit board design. It's usually like one semester or half a semester in an electrical engineering degree, but it's these industry conferences when you talk about like Eric Bogotan, like Lee Ritchie, Rick Hartley, Susie Webb, these industry icons that have been there and that are still doing their business and handling business, of sharing these golden nuggets to the world of what they're doing in the industry. That's where you get that education. And I agree with you wholeheartedly. With that said, we think of, especially since you and I are veterans now, we've been around now for a long time. We've seen the industry evolve. We've seen the tools evolve. We've seen the designers evolve. As an experienced designer yourself, what is some of the advice that you would give to the new generation just getting started in their career about design automation?
So I thought about that question quite a bit. And I thought about my beginning. This is audio only, but behind me, I have a version of a tape out that was hand taped, right? It's on my wall behind me. Now that's a network. So when I started out, we were doing hand taping. So what that means, you have a big piece of Mylar and you're putting in tape one by one, traces and pads and everything. And that really gave me a lot of experience that I use today. So my suggestion is to, as regards to automation and PCB design, is do everything manually first. Don't depend on the automation, even if it's there. Do it manually, learn the ins and outs, because two things, you'll learn better, you'll know the basics better. And if that automation ever quits working, you'll know how to keep going at 2:00 in the morning when tape out's the next day. So it's good to know not just automation, but what's underneath the hood of automation. Looking back and learning from my experiences, I'm glad I did tape. I'm glad I learned from basically the bottom up. And that made me appreciate all the automation that's out there today. When I look at things like the Sketch Router, Sketch Planner, XSI, and unraveling VGA balls, it's like we've come a long way. But if you start right there, you won't learn the basics. So my suggestion is learn the basics first.
You've got to have a solid foundation, and the foundation is the meat and potatoes. You've got to have a solid foundation to utilize this horsepower. I will be the first to tell you is you need to understand how to design a board correctly. It doesn't matter which tool you use. If you don't know how to design it correctly, you're going to design garbage, and you're going to waste money, waste time, and chances are you're not going to be employed for very long, or you're not going to be paid very well.
Just to go on with that, I think your environment, your managers, your engineers will see that, and they'll see that dedication, and they'll see that hard work. And that's what's gotten me to where I'm at today.
That's awesome. That's awesome. You know what? I'll end it there because we're definitely running out of time here. We've talked a lot about automation, and I could go on and on, but we're running out of time here, John. So I want to thank you for sharing your insights on design automation. It's been great. So everyone tune in next month for a look into PCB thermal management. That's going to be another great topic.